Hello and welcome back. Uh, Today we're going to talk about one important theory component in terms of distributed systems. This is called as cap theorem. We'll also move on to acid and then to the base theorem. What do these actually mean and why these are important? So before we get into this, let's try and understand why do we actually need to talk about it. So when we talk about distributed systems, so in distributed system, we can't just work with the traffic going in and out from somewhere and somewhere to else. And so we need to think about how do we actually manage the data, right? End of the day, it's the data that we are trying to get into the system and ensure that that is reflected correctly whenever it's been retrieved or it's been used for some kind of business processing. Now these processes are actually driven with some trade-offs, right? But before we even actually get to the implementation of it and then try and understand the trade-offs, we really need to understand what is that we need to do in terms of ensuring the database is available for the distributed systems. So when we think about distributed systems, the database is actually driven by one very common theorem called as a cap theorem. Now cap is an acronym. It stands for consistency, availability and partition tolerance. So what does this mean is, so at any point in time, so these are the 3 points wherein C, A, P are 3 different things, and at any point in time you can only achieve either of these two. So what that means is you can have CA, CP or AP. Okay, but what does this actually mean? Let's try and understand with partition tolerance first. So partition tolerance means the systems try and talk to each other. So there will be some network issues and there will be some packet drops and all that stuff, right? So that is pretty much common that we see in the networking systems, and we have to ensure that we are protected from this. So that means we can't have any we can't have any objections to not to have this. So we always need to have partition tolerance built into our system, because our systems are supposed to tolerate the failure in the network and any kind of infrastructure issue. So we can't go away with this. So what are we left with? The two choices. One is a consistency and another is availability. What do I mean by consistency? So whenever data is written to a database, is written to any kind of node, and it has its own database in it, so and it is then getting replicated to another database, and there is a system. Let's say this is how we look at it, right? This is system A, this is B, and this is C, right? So if system B is getting data from system A and writing the data, now system B is some kind of database, and it is supposed to write into system C. Now if system D comes into system D comes into play and wants to access the data, it is bound by the component of consistency. It will always ensure that the data which is held into that system is consistent or not. And if it is not consistent, it's not gonna reply. So that is what we understand from consistent system. Now the next is the availability. So what do we mean by availability? Availability means the database is always available. And when it is always available, it could mean that it's okay for it to be out of sync, but it has to be available all the time. Okay, so that is availability, right? And consistency means you can't have out of the date data available on a different node from the another node, right? So these are two important aspect in terms of making a design choices. What is that I want from a specific database, and what is that I'm ready to give up, right? So in summary, we can't give up P. We got to have this all the time, and the only choice that we now need to make is between consistency and availability. So we will always have a database which will be consistent and available in terms of partition tolerant, and available and partition tolerant. So this actually leads into the two types of database that we have, which I've written over here. So let's try and discuss those and understand what does these actually give us in terms of the database. Now let's talk about what do we mean by ACID, right? So ACID is a compatibility test that we put for the database. So it actually uh, drives the concept of consistency into the database. So what do I mean by that? So there are certain use cases wherein, for an example, we have financial institution or we have data warehouses where we absolutely cannot have any inconsistencies between the data, and we would like that data to be absolutely perfect in all the cases, and we can't really have the mismatch between the databases, because that would actually lead to many problems, not just any. And in that case, we need to ensure that the database is highly consistent in terms of performance and availability, right? So, but that's driven by the four concept or the 4 points that we have here. First is atomic, then it is consistent, isolated, and durable. So what do we mean by atomic? So every transaction that it does, so that could actually mean, right, reading from one database, then updating second one, and the creating entry into the third database, and maybe deleting for the fourth one, right? So these are all four operations, and if any of these four, it actually has to roll back all the operation except for the read one, wherein whatever it has done as a part of that entire transaction, it has to actually roll back. So that's what we mean by atomic. Next is consistent. It means that whenever it is trying to update the database, it is not it is ensuring that the integrity of the database is maintained in all the cases. Isolated, it means that whenever two more than one transaction is trying to make any changes to the database, the data is put into an isolation and handled in a way wherein the other update to the database is not actually corrupting the original transaction that's been done by another particular, or maybe an SQL, right? And the last one is the durable. So what it is actually persisted even if there is a network or a power outage. So that's what we mean by ACID. There are a lot many databases that we see which actually follow this pattern, and some of them are MySQL, Postgres, are pretty standard examples of the database which follow the ACID structure in terms of the data availability. And as we now know that they follow the consistency and the partition tolerance available to us. Next, let's talk about base. So base stands for basically available. So the BA is from basically available, soft state, and eventual consistency. Now we can see from this evolution, we are moving into an available and partition tolerant database. Right. So what does this mean? Is the database is always available. So that means the data is always available for application to consume. Soft state means the data is not consistent within the system or within the database, and the data returned for each query could be different. So it is left to the developer how do they actually manage the data and the state of that particular data. And it doesn't mean that it won't be consistent, right? So it will eventually be consistent, right? It could be a little bit delayed, maybe few seconds or maybe few minutes into system, but it will eventually be consistent. And that's what the last eventual consistent means, right? And this is what this is something which drives the use cases around marketing campaigns or the or the reference data that we have, right? So these types of datas are not really need to be atomic in nature or need to be ACID compliant, and we can actually have something which is available at a eventual consistency way, and we can make use of that in an application. So the recent spike of the databases that we see in NoSQL are something which is base compliant. So even if we see that in cloud, so if Amazon DynamoDB is something which is a base compliant database. So this is what we see in terms of the databases which we can use in the distributed system. And these theories actually drives a lot of decisions that we make as an architect. and this actually helps us drive or ask the right question, and then come to the right design. And that's how we design these. Well, that's all for today. Thank you very much, and we'll speak soon. Bye.